Alright, it's time for the daily elite code. Hopefully I can solve in a reasonable amount of time. Alright, two sneaky numbers of Digitville. And the 10, there was a list of numbers called nums containing integers 0 through n. I'm assuming n is given. Okay, no, it's not. Each number is supposed to appear exactly once. Your task is to find these two sneaky numbers. So this is definitely just a step problem, I mean. Okay, probably do another problem after this. So we're just gonna have a scene set and just add it to a scene set every time. Scene res is gonna be equal to nothing, and not in res, and there's only two of them, so this would be a fast lookup. But the constraints are so small that it doesn't matter. I think I'm gonna do a different problem today. Yeah, that was pretty pointless. I'm sure there's some better solution though beyond this set. Beyond the set way, like there has to be some like O of one space way. And I'm sure that's gonna be like the follow-up question. Is there? Oh wait, can you just go to the next daily question? Oh, what the heck? I did not know you could just go ahead. Oh, that's pretty interesting. Okay, let's see if this is solvable in O of one space. If it is, I'll try to do that solution. If it's not, then we'll be done here. Interesting. What the fuck? Okay, if this was a follow-up in an interview, I'd be totally screwed. And makes sense. The expected sum also makes sense. Let two duplicates be A, B. So what? The duplicates mathematically so starting to work. I see. So the sum should be something, and the sum of squares should be something else. Okay. I think we can do this without relying on chat too much. So that's the O of N, like trivial solution. I was not going to come up with that by myself though, so I just decided to look it up. Okay, what's the O of one space solution? They're given that N is side of the list, and the numbers are 0 to n minus 1. So basically, what does that mean? It means that the actual sum of lists plus the projected sum, or sorry, minus the projected sum, is going to be equal to the sum of A and B, which are your two sneaky numbers. And then This equation is also true for the squares of lists. And then this will be a squared plus b squared. And then you could just solve for a and solve for b respectively. So where's the square? Squared and solve for a and b respectively. So the first step is going to be getting the sum of nums. Projected sum is going to be equal to project. Okay. There's definitely some nice syntax you can do for this, which I'll try to remember. Is equal to 0. That's your initializer. And this is going to be equal to projected sum plus I for I in range length of the nums. Right. Yeah, I do want to just see if this syntax is correct. All right, maybe I'm not cooking. Dang, is this not valid syntax for Python? All right, I guess you do have to just do it the normal way. And then your actual sum is going to be the sum of nums. Projected squares. It's going to be like the same thing. So we can just combine these together. And then we're going to add the squares of I to the power of 2. And the actual squares would just be iterating through nums. Might be a little bit nicer to just include the actual sum in here too. Make sure that we print everything, which is expected. And we're going to also want to print the projected ones, I mean the actual ones of the squares. Should have chose a better variable name. I really wish LeetCode had autocomplete. Okay. That's right. The length is gonna be too big. So it should actually be like this because you don't want to account for the numbers. Okay, so the projected is 1 and the actual is 2, which makes sense on this one. 0, 1, 2, 3, 4, 5. And you want to add 0 plus 1 plus 2 plus 3, so it should be 6. Okay, great. So what's A and B gonna be that you can like substitute it as? Well, what equations do you have right now? The actual minus projected is going to be A plus B. So in other words, A is equal to the actual sum minus the projected sum minus b. And we're just gonna have to translate this into code later. And we have to rewrite this in terms of projected and actual sum. Similarly, the actual squared minus the projected squared is equal to a squared plus b squared. So what does this mean? How can we rewrite this equation? We can just plug in the actual minus projected minus b, which would make sense. Let's just make sure. In this case, what's our actual and our projected? Our projected is 6. So I can say A is equal. Sorry, our projected is 6. So 11 minus 6 minus B. And for the squared parts, we got 27 minus 14 is equal to A squared plus B squared. So A is equal to 5 minus B. And this would be a 13. So 13 is equal to A squared plus B squared. So you can plug this in right here. 13 is equals to, gosh, what is that? You gotta FOIL this. One plus B squared. Just means that 13 is equal to 25 minus 2B plus B squared. Right. Wait, am I tripping? Where did I get the 2B from? Oh, that's a 10B. Hold up. 25 minus 5B minus 5B plus B squared. Man, doing this pragmatically might be a little bit tricky. Hmm. And then you have like the quadratic equation. And then you would solve for B. Your A in this case would be 2, then negative 10, and then 12. And your expected is 3 and 2. So how should we do this pragmatically? So we can look at this in terms of deltas. So first of all, the most important thing we need is the difference between projected, which is going to be the actual minus the projected. Oops. Hmm. And then you're also going to need the difference between your squares, which is going to be the actual, what did I name this? Squares minus your projected squares. That means that you're going to just follow this equation where A is equal to 5 minus B. So what's your A term going to be in the quadratic form? Or I guess is it your C term? I forgot this completely. Oh yeah, it's your C term, your constant. So your C term is always going to be your delta squares, like the difference between delta squares and delta sums. Is it? I might be geeking. I'm tripping. C is going to be equal to the delta sum squared minus the delta squares. B is going to be equals to just 2 times your delta of sums, or -2, I mean, times your delta of sums. B squared is going to be, oh, sorry, I guess your A term, I mean, is going to be 2. Is it always going to be 2 though? I mean, you're always going to follow this formula, right? So it's just always going to be in the form of this one squared minus 2 of these, with this as a coefficient, plus another one of b squared. Okay, and the quadratic formula, wow, I never thought I would use this in my life, is x plus or minus the square root of, what is it, b squared? Negative b. Negative b plus minus the square root. Wow, they asked you this in an interview, they do not want to hire you. For real. It's gonna be x, negative b plus or minus the square root of b squared minus 4ac, I believe. Minus 4ac all over 2a. Okay, so what's a good pragmatic way to do this? We just find the square root of this. So square root is going to be equals to b squared minus 4 times a times c. This is going to be the power of 0.5. And x positive is going to be equals to negative Pretty sure you could just do this in Python where you attach the negative sign. If not, that'll be very annoying. Negative p plus the square root divided 2 times a. Then just going to return the positive and negative. I believe. Hopefully this is correct. Oh, we're so cooked. Let's see if we at least got the coefficients right. Okay. And make sure that our deltas are correct as well. This would be very annoying to debug in an interview. I feel like I'd be like shitting bricks. Delta squares. Let's see where we fucked it up. Oh, we're actually correct. Wow, I'm geeking. We just need to forgot to typecast it to an integer. Okay, fire. I feel like I would not have came up with the intuition to make it a system of equations. How is the runtime worse? There's actually no way, bruh. I'm gonna gamble for a better runtime. Because I'd not do all that work just for it to be less or be more slow. Oh, there you go. Probably like I'm guessing the topic's gonna be hashing or like sets and then probably number theory. Oh, okay, math. That's okay, yeah. What is going on with this platform? Interesting. I don't think anyone's really talking about. Oh, I just saw someone talking about the constant space solution. Yeah, I guess this is a good trick to remember. I remember there's another problem that had a similar intuition where you literally just had to complete the system of equations, but the problem was hella long and it's like very hard to come up with intuitively. Oh, it's called what other problem? Only code was thought by just coming up with. Yeah, it's not this one. This was like Floyd Marshall algorithm. I still remember some problem with it where it was like you had to do the squares as well. Alright, that wasn't too bad. 24 minutes for the follow-up and the normal.